Hey Chemistry, Mrs. KJ here, going over A.04, the periodic table. First of all, groups and columns. Where are they? What direction do they go? They go vertical or up and down. So here we have group 1. Here we have group 2. This is also a group. It's called 6B as in boy. Here's another group. Here's another group. Our noble gases at the end are another group or column. Usually we call them groups, though, more often than we call them columns, but they mean the same thing. Along with our groups and columns going vertical or up and down, we of course have them in two sections. We have group A and group B. Group B is in the middle, and we don't talk a lot about them in this class. Group A we talk about a lot. We have 1A, 2A, skip, the messy, middle, transition metals, 3A, 4A, 5A, 6A, 7A, 8A. And the nice thing about group A is the number of valence electrons. Okay, where are valence electrons? In the outermost shell. The number of valence electrons is the same as the group number. So this is group 2. It has 2 valence electrons. This is group 6A, 6 valence electrons. So elements in the same group not only have the same number of valence electrons, but because they have the same number of valence electrons, they also have similar properties. So lithium, sodium, potassium, they all react when you put them in water. They start on fire, they explode, they have similar properties. So let's talk about periods and rows. Periods and rows go horizontal, or in other words, left to right. So row 1 is hydrogen and helium. Row 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Row 3, row 4, row 5, all the way to the end, row 6, and row 7. Now, as you go from row 1 to row 2 to row 3 to row 4, as you go down, each one of these has one more what? Think of the Bohr diagrams when you draw them out. They each have one more orbital. So row 1 has 1 total orbital. Row 2 has 2 total orbitals. Row 3 has 3 total orbitals or shells when you draw them for Bohr diagrams. Which groups are very reactive? All right, so we got to think back to why do atoms react? They react in order to get a full outer shell. So which two groups are the closest to having a full outer shell? It would be groups 1A, forgot to write the answers in here for you, 1A and 7A. And the reason is 1A has how many valence electrons? 1. So it really wants to lose that one outer electron to have a full outer shell. Group 7 only needs 1 valence electron. It really wants it. So they are very reactive. This group is not reactive at all. The noble gases are not reactive. Why not? They already have a full outer shell. All right, so quick review of group names. What do we call group 1A? They are the alkali metals. They're in yellow. Now, be careful, even though hydrogen's over there, it's technically not an alkali metal. It is a nonmetal. So why do we throw it over here? Because it only has 1 valence electron and it is very reactive. All right, group 2A is called what? The alkaline earth metals. In the middle, all this purple, these are my what? Transition metals. If I look at group 7A, those are my halogens, and group 8A are my noble gases. Now down here we have the lanthanide and actinide series. They're series, not groups. They technically fit right in there, but there are other things that you may need to know at some point on your periodic table. Now, usually this group is just called the boron group, the carbon group, the nitrogen group, the oxygen group, but even that, you don't hear it called that very often. So really, you just need to know alkali metals alkaline earth metals. Know your transition metals are in the middle. Halogens, noble gases. And we also call these down here the inner transition metals, which of course is because they really belong right in there, even though we throw them at the bottom. How else can we organize the periodic table? Well, we can organize it into metals, nonmetals, and metalloids. So on this table, what color represents metals? That would be the red. What color represents the nonmetals? That would be blue. And what color represents the metalloids? The yellow. So metals, hit pause. Think of at least 3 properties of metals. They are shiny. They are ductile, meaning we can pull them out into wires. They are malleable, meaning you can hit them with a hammer and make them into different shapes. They conduct heat and electricity very well. Nonmetals. Oops, sorry, should have had that on this slide. Nonmetals. Nonmetals. Give me a few properties of nonmetals. Hit pause, get at least 3. Nonmetals are dull, brittle, do not conduct heat and electricity very well. So some can, but really poorly. All right, metalloids. How would you describe the properties of metalloids? Hit pause, get an answer. Metalloids are between metals and nonmetals. And so some of them kind of conduct. Some of them are kind of brittle. Some of them are kind of shiny. Some of them are kind of brittle. They're the kindas because oid means somewhat or like, or in other words, kinda. All right, this one was short and sweet. So go ahead, do the worksheet, and then go ahead, look at the answer key and correct your own worksheet. Come for help to your teacher if you need it. Take the quiz. After the quiz, check which ones you got wrong, if any. If you still have questions, please come see us. Remember, knowing metals, nonmetals, metalloids, that's going to be important for the next couple units, so make sure you have it down. All right, have a great day.